The idea is that in real life, we sometimes are faced with the situation of square root of a negative number, right? We just discussed this. The square root of a negative 1, what we say instead of stopping and saying no solution is we say, okay, that's I, where I stands for some imaginary number. Okay? So in other words, for example, if we had the square root of negative 25, for instance, what we would first say is, okay, well, because that's a negative, I'm going to pull the negative out and turn it into what, guys? Yeah, but to make it, oh, stop that. To make it a positive, I'm actually going to pull the I out, okay? Like that. And now it's positive up under. So you're right. Before I can evaluate any square root, honestly, any even square root, but we usually deal with normal square roots, okay? So I pull out my I, and then square root of 25, what is it? So we would say, okay, this is equal to 5i. So I didn't show you guys that a second ago, but you see the idea how it kind of passes straight over? In other words, you get rid of the negative by pulling it out and making it an I, and then you have your normal answer to your square root. Okay? So 5i is considered a complex piece of what a complex number is. A complex number in general can be written with the regular number plus some other number attached to I. Really can be plus or minus. So for example, a moment ago, you guys saw something like negative 5 plus 9i. Negative 5 is the real number, right? And 9i is the complex one. I mean, excuse me, the imaginary part. And it's complex because it's a combination, right? Just like with anything, you can have something like this, 5i, where it's only the imaginary part, or you can have normal numbers where there's not the imaginary part, or some combination like up here where you have both, okay? Generally, we write the I second and the real number first. Something else to notice as we start doing operations is that I squared, anytime you have an I times an I, what's I squared equal to?
Negative 1.
Negative 1. Because basically, if you look up here at the top one, if you square on the right and then square on the left also to cancel that square root part, you're left with negative 1. Good, cool. Let's see. Let's look at one other example similar to square root of 25. This is example 1 from your text. It is, I'll just put an example from the textbook. It's negative square root of negative 50. So even though they're trying to confuse us here, guys, the idea is let's deal with what we don't like first, which is what?
That negative underneath the square.
Yes. I'm sorry. So how do I deal with that? Yeah. So I'm going to take this negative and then pull it out by turning it into an I, right? So I have a negative, I have an I. Sorry about that. And I have a 50. We can actually do more stuff by hand, can't we? Remember when we used to, yeah, we're going to do the square root, but this one doesn't have a perfect square, does it? What we can do, though, is we can remember that using the prime factorization tree, like this, we can find those pairs, right? What's something that's out?
25 and 2.
Okay. You guys are already saying, you're saying like 10 and 5. I personally, I'm pulling out with the left. Like I do it too. 25 and 10 work too. You get there pretty fast with that. But what, is it okay if I write it the way I usually do in class? Yeah. Okay, so normally I would put a 2 and then a 25. And then I would keep breaking it. Your ways are also correct. Remember that the goal here is to write it in the smallest piece as possible. I'm just really, really structured with the fact that I always pull out the smallest and put it on the left. I don't like this number over here to get broken. So that's why I did that. Okay, what's something that comes out of 25? It's the smallest piece. 5, perfect. And then another 5, right? So this is the prime factorized, or prime factorization of 50. What are we looking for again, guys?
Let's get the same number.
Yeah, 2 of the same number. So if I cancel that, I'm going to pull this out. And this 2 that didn't get messed with, it's going to stay up under the bar, right? That's what we always do. So in other words, we have negative I, 5, and the square root of 2. Now we don't actually leave the answer looking like that. We're going to reorder it. The way we would usually write it would be negative 5 coming first. We like to put the normal number parts in the front if possible. Okay? Then we have square root of 2. Then we have I. Now guys, you know, just like from anything else in math, you can mix up your x's and y's and stuff. It's the same piece. Every piece of this is attached by multiply, right? That says negative 5 times square root of 2 times I, right?
It might be the same no matter what.
Yes, it's the same thing no matter what, but as far as writing it pretty and getting familiar with how the book's going to expect it, or the My Math Lab, it's like that, with I at the end. That's not too bad, is it? Okay. Let's see, what other stuff do we have? The idea of adding these things. Add a page. How do I add a page? Oh, okay. So more examples, let's do some adding and subtracting. Basically, when you add and subtract, you're doing it just like you normally would be with x's, right? Or any other variable. So here's an example from the book. It's example 2. If you guys want to try to write some point, you can do. Okay. So I have 8 plus 6i. Oops. You can take it away.
What's the eraser in?
I don't know. Okay, that one. That'll be it. There we go. That worked. Okay, so we said what, 6i? I feel like I'm playing a video game or something. And I'm not good at video games.
It's tough to write on them without seeing which one.
That's right. Okay, then we have plus 3 plus 2. I'm impressed at how it's connected very well. The response time shrinking. Okay, so adding and subtracting these things, they've got it in parentheses, guys, because it's like 2 different numbers. Here's the first one where 8's the real part, right? And 6i, that's the what part? Imaginary part, yeah. The thing as a whole is called a complex number. So here's one complex number plus another one. And the way we add it is just like we would with normal variables. You add the like terms. In other words, 8 plus 3 gives me what? Sounds good. 6 plus 2? Okay. And then I have my I still in there because that was a like term. Done. Adding and subtracting is always going to be easy. Let me show you the hardest time it could ever possibly happen. Well, one of the hardest times. I mean, if they add multiplication and stuff, you guys know from normal math, that can always get a little uglier. But the idea will always follow that you treat this just like you would a variable, x, and the only difference is at the very end, you will continue to remember that idea that I squared equals negative 1. This is also a part of example 2. I'm not doing the entire example, I'm just kind of doing parts of it. But here's another part of the example, example 2. That's supposed to separate. Okay, help me out, people. What's the first thing I should do?
Check the real numbers.
Okay, so you're saying,
Or should you like turn it on to the opposite?
yeah, go ahead and distribute that negative so you don't have to deal with it. That way you're thinking subtraction. So I have a negative 6, and a positive 3i. And then I can just put real number, or like terms together like I usually do. In other words, what's a 4 and a negative 16?
-2.
Perfect, negative 2. And what about 5i and 3i? Okay, positive 8. And the I stays on there because that's the way you normally do this. They were like terms. Good. What about multiply? Let's look at the next one. All right, okay. What about something like, that's lame, oh goodness. What about, we'll do an easy example. Example 3, I'm kind of following the book to these. One part of example 3 gives you something like this: the square root of negative 16 times the square root of negative 25. What's the first thing I have to do before I even think about multiplying?
You're in the negative.
You're in the negative. In other words, do what?
The imaginary, like just pull the negative out and put put I in front of it.
Okay. So in other words, here I'm going to make an I.
Yeah.
Square root of 16 times I square root of 25. Okay, that was good, Andy. Hey, Brandon, what's the square root of 16? Hey, Andy.
4.
4. What about 25, you guys?
5.
Perfect. I agree. So in other words, here we have 4i times 5i, right? And you treat this just like you would anything else. So 4 times 5 is what? 20. I times I is going to be I squared, okay? And of course, we know that an I squared is the same thing as a negative 1, right?
Yeah.
Okay, that's the hardest step right there. At the very end is remembering to replace your I squared with that negative 1. It's being multiplied. In other words, our answer was what? Cool. I'm doing it. Also, it's kind of fun getting to see things. Okay, let's do another one that has multiplication happening. How about, and this is still in example 3. I'm skipping around though, even though I'm in the example, okay? So, anyone reading the textbook and going along with us, you'll notice that I'm leaving out certain parts so that you can read some of your book also, in addition to this. So here's another part, and this is actually part B of the example. This was part A again. Okay, so down there, what should I do, guys? Multiplication. What's happening? Yep, I agree, Brandon. Distribute. Negative 4 times a positive 3 gives me negative 12.
12.
I have my I, beautiful. And then negative 4 times a negative 5.
Positive 20.
Sounds good.
Square.
Huh?
You square the I.
Perfect. Yeah, I squared. So in other words, what should I do with that I?
Negative 1.
You got it. Negative 1.
And write it the other way.
Yep, we'll split it when we write it. In other words, is equal to what, negative 20? That's the real part.
Yeah.
Then what?
Minus 12.
You got it. Minus 12. Beautiful. The last thing in complex numbers, well, the last main idea, is how to clear out the denominator of a fraction, a conjugate. Hope you guys, you like saw the whole lesson before it starts. So, let's look at another example where we're going to do that.